the function f is defined as f of x is x squared minus 1 over x squared plus 1, show that the only stationary point of the function occurs when x is 0. So, if we say that u is x squared minus 1 and v is x squared plus 1, then we know du dx is 2x and dv dx is 2x. So f dashed x would be v du dx, so that's 2x x squared plus 1, take away u dv dx, so that's 2x x squared minus 1, all over v squared, so that's x squared plus 1 squared. Now if we think about the top, we get 2x cubed, add 2x, and then here we get minus 2x cubed plus 2x, so that's going to end up being 4x over x squared plus 1 squared, and that's only 0 when x is equal to 0. So that's the first part done. We now want to sketch this. Now, if we think about x being 0, that would give us negative 1 over 1, which is negative 1. So this must be that point. Think about x tending to infinity. The negative 1 and the plus 1 make no difference. X squared over x squared is 1, so we must have a horizontal asymptote where y is 1. Now we can see that the zeros of this function would be plus or minus 1, so it must go through this point, and so the only thing it can possibly do is something like that. Using your graph or otherwise, determine all the solutions to these equations. So what I'm going to do very quickly is just take a copy of this graph so that I can draw on it without spoiling the actual graph itself. And then we'll just paste that in here, and we can play with this one down here. So f of x is equal to mod f of x. So mod f of x, what's going to be the difference there? It's actually just going to do this. And so they would be exactly the same from 1 onwards and from negative 1 backwards. So we can say that x is less than or equal to negative 1, or x is greater than or equal to 1. Now we have f of x is equal to f of mod x. Now we know with this one that it's always the same for positive values of x, and then a reflection of that in the y-axis. But this graph is perfectly symmetric, so it seems that all real values would be solutions. Now we have f of x is 1 over f of x, so let's see what happens there. So, well, we know when we have a 0, we'll have an asymptote. And so when this is close to 0, it would be up here. And so that must come down, but this is always less than 1, so we're not going to get an intersection there, and the same is true there. We won't get an intersection because we're dividing 1 by something that's less than 1. That must give us something more than 1. This would be an asymptote, but remember this is negative 1. 1 divided by negative 1 is negative 1, so they're going to intersect just at that point. So it seems that x is 0 is actually a solution.